Hello and welcome to my channel. This is a channel where I attempt to make it easy for you to understand maths. Let's start with linear inequations in one variable. Linear inequations in one variable. First, before we understand what is a linear inequation, let us understand linear equation. So which you have already done in the class 9. That is, ax plus b is equal to c. Because the power of the variable, highest power of the variable x is 1, it becomes a linear equation, and because there is an equal to sign, it becomes an equation. So linear equation will be ax plus b is equal to c is just an example. When I say linear inequation, this linear part remains the same, that is the power of the variable is still 1. But because I am saying inequation, the equal to sign gets converted into an inequality. That is less than, greater than, less than or equal to, greater than or equal to. There are three aspects to this particular chapter, that is solving the linear inequation algebraically. Second is, after I solve the inequation, I am going to write the solution set based upon what is the replacement set or the domain set, and then representing the solution set on the number line. Now there are three rules that you should keep in mind while you are solving the linear inequation. So the first one being, when a term is shifted from one side of the inequality to the other, the sign of the term changes. This is same as what you had earlier had with respect to the linear equation. So for example, if I have like this, that is 4x minus 5 is greater than or equal to x plus 10. When I am shifting the term from one side of the inequality to the other, that is, suppose I am shifting x to this side and minus 5 to this side, then this is going to be 4x. This is a positive, x is positive, this will become negative over here. The inequality will be as it is, and this is 10, and because minus 5, that is 5 is negative, when it comes to the other side of the inequality, it will become plus 5. Now let's look at the next rule. When each term of the inequation is multiplied or divided by a negative number, the inequality reverses. So for example, suppose you have minus 7 is greater than or equal to minus 2x. When I multiply, because I want to convert the minus 2x to plus 2x, so what I will do is I am multiplying minus 1 into minus 7. This inequality that was greater than or equal to will become less than or equal to, and then this is going to be minus 1 into minus 2x. So that is effectively this is going to become 7 is less than or equal to 2x. Even further simpler example will be like this, that is, suppose I have minus 7 is less than minus 5. You know that minus 7 is less than minus 5. But when I multiply by minus 1, that is, this 7 you know is going to be greater than 5. Okay, then the third rule, when both the sides of an inequation are positive or both are negative, on taking the reciprocals, the sign of inequality reverses. So let me take the example as, so if x and y are greater than 0, then, and if x is greater than y, then on taking reciprocal, this is going to be 1 upon x will be less than 1 upon y. Example is like this, that is, suppose I have 7 and 5, you know 7 is greater than 5. But when I take the reciprocal, 1 by 7 is going to be less than 1 by 5. In the same way, for the negative numbers, if I have minus 7, you know that minus 7 is less than minus 5. When I take the reciprocal, this is going to be minus 1 upon 7 is greater than minus 1 upon 5. Remember that you are only taking the reciprocal, you are not multiplying by minus 1. You're not converting that minus 7 into positive. Go step by step. So this is minus 7 is less than minus 5. This implies when I take the reciprocal, minus 1 upon 7 is greater than minus 1 upon 5. Representation of the solution on the number line. So after you have solved the given inequation algebraically, depending upon the variable, the domain of the variable or the replacement set of the variable, our solution is going to change. So I am showing you, giving you 5 examples over here in order to make you understand how the replacement set n or r or w or z makes a difference to the solution. Consider this. X is greater than 2 and x belongs to n. It is only greater than. So, and because it is natural numbers, that is 3, 4, 5, 6. So you are greater than 2, which means that 2 will not be a part of the solution. But when I say x is greater than or equal to 2, then my 2 is included in the solution. So our representation will be like this. When I say x is greater than 2 and x belongs to R, not n, not the set of natural numbers, but the set of real numbers, then it means that because it is greater than 2, at 2 you will make a hollow circle, and from 2 all the values going infinitely in greater than 2. So that is, you are talking about all the values in between 2 and 3, in between 3 and 4, in between 4 and 5, and therefore you are drawing, shading the line in between over here to show x is greater than 2 and x belongs to R. When the solution set is minus 1 is less than or equal to x is less than 2, x belonging to z. Again, integers, there are no integers between two integers. Therefore, your values are going to be independent 1, 2 and 3. Because it is less than or equal to, your minus 1 is included in the solution. 0 is included, 1 is included, but because it is x is less than 2, only less than and not, there is no equal to sign over here. Therefore, you will not include 2 in the solution set. Now look at this one, that is minus 2 is less than x is less than or equal to 3. Because x belongs to R, all the values in between have to be included, and therefore you are taking a dark line like this. Because there is no equal to sign over here, minus 2 is a hollow circle, and because 3 is less than or equal to 3, therefore your 3 is going to be a dark circle. Now these are just a few examples that I have explained. Let us look at individual questions and solve them, and then see how we represent that on the number line. Consider the question, find the largest value of x for which 2 into x minus 1 is less than or equal to 9 minus x and x belongs to w. So here this is the inequation that I have to solve. X belonging to w, which means that my w is the replacement set. That is, where does x come from? It comes from the set of whole numbers. So the value of x that I have to find out is going to be from the set of whole numbers. So let's solve it. This is going to be step 1. That is, step 1 is the solving of the algebraic equation. 2 into x minus 1 is less than or equal to 9 minus x. This implies 2x minus 2 is less than or equal to 9 minus x. This implies 2x plus x is less than or equal to 9 plus 2. This implies 3x is less than or equal to 11. This implies x is less than or equal to 11 by 3, or I can also write this improper fraction as mixed fraction, that is 3, 2 by 3. Therefore, the step 2 that I am going to write down is the solution set. That is, solution set is going to be equal to all those x variables x such that x is less than or equal to 3 2 by 3 and x belongs to w. This is very important for you to note. Where does x come from? X comes from the set of whole numbers. This implies that your answer is also equal to, can also be written as, because your set of whole numbers starts from 0, I'll write down 0, 1, 2, 3, and I will not write 4 over here. I will not write 4 over here because you are saying that my x value x is less than or equal to 3 2 by 3. That means it has to be less than 4. My 4 will not be in this, and therefore I remove the 4 and I write down only till 3. Which implies my question is what? Find the largest value of x. So therefore the answer will be the largest value of x is 3. Solve the inequation 3 minus 2x greater than or equal to x minus 12, x belonging to n, and then represent it on the number line. So in this question, I am going to first underline what am I talking about. So this is going to be, this is your algebraic expression which I have to solve. X belonging to n, that is my n is the replacement set or the set from which my values of x are going to come from. And so we start with the first step, that is solving the inequation. 3 minus 2x is greater than or equal to x minus 12. I bring the 12 this side and take the minus 2x this side. That will give me 15 is greater than or equal to 3x. This till here, all that you have done is simply your class 9 work. You are taking the term from one side of the inequality to the other side. When you are shifting the term from one side of the inequality to the other, the sign of that particular term, only of that term, changes. That means your minus 2x becomes 2x and minus 12 becomes plus 12. So when I simplify this, 15 divided by 3, I get 5 is greater than or equal to x, which I can also write as x is less than or equal to 5. Therefore, my solution set is going to be x such that x is less than or equal to 5 and comma x belongs to n. The same solution set, when you think about it, I can also write it as, because x belongs to n, and that means starting from 1, all those numbers, all those natural numbers less than or equal to 5. So I can also write the solution set as 1, 2, 3, 4, 5 between brackets. When I want to represent it on the number line, this is my normal number line, but I'm only going to select the points 1, 2, 3, 4, and 5. Now suppose that I want to solve the same inequation, that is the algebraic inequation is the same, but my replacement set is now x is belonging to w, that is x is coming from the set of whole numbers. All this remains the same, but because x belongs to w, I am also adding a 0 to my solution set. When I'm writing here, there is no problem. I can simply write the same thing, but because you're saying x belongs to w, be very careful. This is very, very important. Without you writing where x comes from, there is no meaning to your solution set. And therefore your number line is going to have one more value of x, that is 0. If 25 minus 4x is less than or equal to 16, find the smallest value of x when x belongs to R and find the smallest value of x when x belongs to z. I have taken this question to just so that you are able to understand the importance of the replacement set, or from where your x is coming from, what is your domain. So let me first step, that is solving of the inequation. 25 minus 4x is less than or equal to 16. I have left minus 4x over here and 25 I've taken to the other side. So since 25 was positive is this side, it becomes negative. So this becomes minus 9. Now in my previous slide, when I gave you the steps, I had explained that if you are multiplying or dividing by a negative value, your inequality changes. So since this is minus 4x is less than or equal to minus 9, if I multiply by minus 1, that is minus 1 into minus 4x, my inequality changes. That is, this will become less than or equal to will become greater than or equal to, and this is minus 9 into minus 1. So this will become plus 4x is greater than or equal to plus 9, that is x is greater than or equal to 9 by 4. And I write the solution set as, so I am attempting over here when x belongs to R and x belonging to Z. So solution set for the first one, x belonging to R, this is going to be x is greater than or equal to 9 by 4. I write the improper fraction as a mixed fraction as x is greater than or equal to 2, 1 by 4, x belonging to R, which means my x is, so first what you do is you plot 2, 1 by 4. 2, 1 by 4. So it is more than 2. So I will write down over here. I am dividing between 2 and 3. I will divide it into 4 parts. So that means this is going to be my 2, 1 by 4. Because you are saying x is greater than or equal to 2, 1 by 4. So from here onwards, I am going to take all the values. Also, because you are saying greater than or equal to, which means this here you are going to have a proper, not a hollow circle, but a dark circle. So the smallest value of x is going to be, when x is belonging to R, the smallest value x is going to be 2.25. That is 2, 1 by 4. But when x belongs to the set of integers, I am going to take 1, 2, 3, 4. That is, I have divided it into 4 parts. And 2 is greater than 2, 1 by 4, meaning it has to be greater than this. But because x belongs to z, that means this value, though it is 2, 1 by 4, it is no longer in the solution set, and my solution set will be start from here. 3, 4, 5, 6. So the smallest value of x is going to be, x is going to be equal to 3. Do you see the difference between this answer and this answer? Only because there is a change in the set from which you are taking the values of x. Here x belongs to R, and therefore because you know the 2, 1 by 4 is a part of R, your smallest value is going to be 2.25. But here, because x belongs to z, that means 2, 1 by 4 is not a part of the set set of integers, and therefore the smallest value of x when x belongs to the set of integers is going to be 3. Solve the inequation 12 plus 1 5 by 6x is less than or equal to 5 plus 3x, and the replacement set is x belonging to W, that is a set of whole numbers. Let's try to solve this one. So I write it down again, that is 12 plus 1 5 by 6x is less than or equal to 5 plus 3x. I will convert the mixed fraction into an improper fraction. So that is 12 plus 11 by 6x is less than or equal to 5 plus 3x. I'll take the LCM on the left hand side. That will give me 72 plus 11x. Whole thing divided by 6 is less than or equal to 5 plus 3x. I will take the denominator to the other side. So that will give me 72 plus 11x is less than or equal to 30 plus 18x. I will shift the 11x to the right hand side and bring the 30 to the left hand side. So that will give me 72 minus 30 is less than or equal to 18x minus 11x. So I will get 42 is less than or equal to 7x. And that will give me 6 is less than or equal to x. So when I write the solution set, this is going to be solution set equal to all those x's such that x is greater than or equal to 6 and x belongs to W. Remember that here it is either I write down 6 is less than or equal to x or x is greater than or equal to 6 is one and the same. I can write the same solution set also as 6, 7, 8, 9 and dot 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 because it is greater than or equal to 6. All the numbers greater than or equal to 6 and they should be from the set of whole numbers. Now let us do the same question where the replacement set is R. Now as you can see over here, I have changed the replacement set to R. That is x is coming from the domain of R, set of real numbers. Now I have to do the whole solution is the same. But when I write the solution set, I am writing down x such that x is greater than or equal to 6 and x belongs to R. Now how will my solution be over here? That is on the number line, how am I going to write it? This is going to be x is greater than or equal to 6. Therefore, I am going to have a solid circle and then I am going to draw a line like this and shade everything from here. So this is going to be the number line, representation of the solution set on the number line.